In this video, we will take a look at more surface high-speed machining, in particular the waterline finishing techniques. This model, so far, I have roughed with a core roughing and a core roughing rest milling operation. I also have a surface high-speed horizontal machining operation, finishing off the horizontal flat areas of this part. To create a waterline toolpath, I'm going to right-click, copy after that horizontal toolpath. The nice thing about copying your toolpath is all your geometry, your drive surfaces, and containment boundaries come with it. You don't have to reselect anything. So I'm going to go to my parameters here, change this to a waterline. Now I don't want a containment boundary anymore. I want this entire model machined. So I'm going to cancel the containment boundary, move down to my tool, and I'm going to select a bullnose end mill, 1/2 inch in diameter. I'm going to move into my cut parameters here, and for a step down, I'm going to have 0.010 of an inch. I can change my cutting method to climb, conventional, or zigzag. I'm going to leave this on climb milling here, turn my add cuts feature off, turn my rest passes off, and stock to leave 0. Now go into transitions here. I'd like a tangential ramp between Z-level cutting passes. Steep shallow. Now to see what this looks like to start with, I'm going to machine the entire model inclined surfaces from 0 degrees to 90 degrees. I'm going to turn Z-depths off, and let's put a filter on this toolpath so it processes a little bit faster. Click OK, and now I need to regenerate. Now this may take a minute or two, especially for a finishing toolpath, so I'm going to pause the video and resume when regeneration is complete. Okay, let's now go ahead and backplot and take a look at what we've got here. You will notice that this toolpath is very similar to the traditional Mastercam surface finish contour toolpath. It takes constant Z-level cuts. However, the motion between passes is very smooth and fluid, akin to all the surface high-speed toolpaths. Let's go ahead and verify that. Now for my stock source here, I'm using an STL file that I created by saving my previous roughing operations. Okay, and there's our completed part. Now let's go ahead and make some changes here. I'd like to try and eliminate machining these shallow areas here, where I'm getting some steeper stair stepping, and also around the bases of these bosses where the fillets are. I don't want to machine there. And these shallower bosses, I'd like to finish this whole top area with a different operation. So I'm going to try and limit my toolpath to these steeper bosses. Let's take a look now at how we do that. Go back into my parameters and the steep shallow section. Here we can limit the angle to what this cuts between. Now it's important to note that this is from a horizontal measurement. Let's go back into our model here. I'm going to Analyze, Dynamic, and I'm going to click on this boss right here, this shallower boss. And you can see here my angle is about 40 degrees. Now that angle is from vertical. If I go and click on this steeper boss here, we can see this is about an 8-degree angle. Again, that's from vertical. So that's a very handy tool, that Analyze Dynamic. I have an icon created for it right there. So let's go back into Angle here. And now since that was from a vertical orientation, 90 minus 40 to create the complement of that angle, which is 50 degrees. To give myself a little margin, I'm going to make that 51 degrees. Click OK and regenerate. Okay, and our regen is complete. We'll go in and backplot that. And just as we expected, machines only the areas between 51 and 90 degrees. Now for a verify, and it looks pretty good. I avoided machining these two shallower bosses and the shallower areas of this large fillet here. However, there's still some areas that I'm not happy with, in particular the surface fillets between these bosses and the floor here. You can see the angle must be between 51 and 90 degrees, thus it's just hitting that surface a little bit. Now the part isn't gouged, but it is machining those fillets just a little. Let's go back into our parameters now. Let's try 70 degrees. Click OK, and one more regenerate. Okay, let's backplot that here. And we can see the incredibly efficient motion here. It machines this entire boss, moves over, machines the next boss, and then machines the entire outer surface here. So it's really maintaining contact with the part almost the entire operation. Let's go ahead and verify that. And there we are. That looks pretty good now. That's exactly what I was after. I wanted to avoid these lower fillets here and this larger outer fillet. I just wanted to machine the steeper areas and save the rest of the shallow areas for another operation. So there we can see the value in using that surface high speed and especially focusing on limiting the angles that we machine. Here I have a part that's an ideal shape for a surface finish waterline. Now waterline toolpath cuts in constant Z, meaning it takes a pass in X and Y around the part, plunges in Z, takes another pass in X and Y, and so on. It's well suited for machining walls of steeper parts, such as this. Now thus far I've got this part roughed with a core roughing, a rest roughing up, and then finished with a horizontal. Now that's just finishing the flat areas, such as the tops of these small bosses, the tops of this larger boss, and then all the other flats down here. So what that's leaving now is the entire outer region of this part. Create my waterline by starting under Toolpath, Surface High Speed, Drive Surfaces, go into Solid Selection, and then pick the entire model, End Selection, and then Toolpath Type. We have Waterline here, and here we have a small graphic of how Waterline is going to be cutting. And we can see here cutting in X and Y, then plunging in Z, taking another XY pass. For a tool, I'm going to pick a 3/8 inch bullnose tool with a 1/16 inch corner radius, and then my cut parameters. I want to climb cut, step down, tighten this up a little bit to 25 thousandths of an inch, and then I have no stock to leave since this is a finishing op. And tool containment doesn't really matter because I don't have any wireframe selected. Let's go into our steep shallow for a minute here. And I'm going to have angle limiting off and just see what kind of results this gives me. Down into my linking parameters. Then I have my linking move here set to minimum distance. However, the maximum speed my machine can accept is 500 inches a minute. And then I'm going to leave all the other defaults. Check my arc filter tolerance. Tighten up our tolerance here, make this 1/1000th of an inch, and then we're finished in here. And then if we backplot, you can see a very nice smooth cutting motion, just focusing on those vertical stands. Now you notice that I have two different colors in backplot here, orange and blue. Now that's set up in my options here, which is this button, and then my colors. So a linear feed is blue, which we can see makes sense here. And then a circular move, either clockwise or counterclockwise, I have as orange. So by changing the colors, this gives me a great display of what kind of G-code output I'm going to be getting. And I could tell by the different colors here that most of the motion here is arcs, I can have a nice, smooth, fast feed rate. But I'm going to analyze this a little bit further and zoom into this corner here, and we can clearly see from this blue linear move right into this arc motion here. There's no transition or tangential motion at all. Let's go back into the parameters and try and make a little bit of a smooth arc motion here, just to better improve our machine motion. So we'll go back into the parameters on the cut parameters page, and here we have corner rounding. I'm just going to give it a little bit of a radius here, let's say 15 thousandths of an inch. OK. Regenerate. Now if I backplot again, you can see right here just what I'm after. A nice tangential arc, but really helps smooth out the machine motion. If we roll out a little bit, we can see it occurs everywhere where we would have had a hard direction change. And now we can verify this part. Now I'm starting off with an STL file of the previous 3 operations. So we're just going to be seeing the waterline op. And that looks very nice. However, another issue with these corners here, I know that my tool radius is larger than these corners here, so I know that they're not getting cleaned up. And I can go in and analyze dynamic, and if I pick that fillet, you can see the radius is 175, and I have a 3/8 tool diameter, so the radius of that tool will be 1875. So therefore, I know I'm leaving some material in there. So I'm going to create another waterline operation, but just have this one target these crotches here. That's going to be a rest milling operation. So I'm going to take our first waterline, right-click, copy after, go into the parameters, toolpath type, leave it as a waterline, tool. I'm going to switch, though, to a smaller tool. I have an 1/8 inch taper end mill with a 15 thousandths corner radius. Go into my cut parameters, and you'll notice the step down is automatically tightened up a bit here, 12.5 thousandths. That should be okay. But our key parameter now is our rest material here. So first I need to turn trim to stock on. Then I have 4 different ways of how this stock can be analyzed to see what material is left. For this particular application, I'm going to check roughing tool. And just key in the diameter of my roughing tool, which is my previous tool, 375, and the corner radius was 1/16 of an inch. So now this tool path is going to study this model in any area that's tighter than this 375 diameter. It's going to create some cutting passes in for my new smaller tool. Then if we backplot that up, you can see overall it's accomplishing what I'm after, cleaning out just these corners with a waterline style pass. However, it is going into these holes here. We're going to want to adjust this tool path a bit to eliminate that motion. Another thing I might want to modify here, a little bit of excessive lead-ins and lead-outs and looping motion. I just want to tighten this tool path up to get a little bit less motion overall. So we'll go back into the parameters, go down to the steep shallow page. I'm going to turn Z depths on now. Now I don't know what the Z depths are at this part at all, so I'm just going to use my right click and pick Z coordinate of a point for my maximum depth. So I'm going to pick the top of that hole and just add 10 thousandths of an inch. And then my minimum depth, Z coordinate, just pick anywhere up here. We'll round that to an even 2 inches. Now I am going to have a pencil operation to finish all the fillets of this model, so it's not critical that I'm not quite machining all the way down. Now to reduce that motion a little bit, go into the linking parameters and the curl up, curl down, and part clearance. Tighten this up to 25 thousandths for curl up. My part clearance, say 50 thousandths. And then my vertical arc entry, make that 25 as well. And then the arc exit, adjust that, regenerate one more time, and then backplot. You can see that's just what I'm after. Really nice motion, cleaning up those tighter corners. And then we'll go ahead and verify both of these water lines.